Hi my friends, today we model this part which has the name crane hook. It is also taken from the drawings of Timoteo Carrera Soto. As you can see, this is the hook, and Timoteo has a lot of hooks. Look here. Yes, many shapes, many dimensions, and so on. I selected that one because I think it is not too complicated, not too simple. The drawing is this. You see, there is a section here along this line, but this line is sloped. You see here, so that I made a view from C to place this dimension. Yes, radius 25. The shape is interesting. If I let you make for yourself this, do you want to try to create a challenge now for you? Now let me draw the sketches and model the object, because I want you to use a suitable and correct procedure. We start by creating this contour outside, but the first step is to create this horizontal line at 33 length and 100 from the center point. This is the center point. There is a radius of 30 in the center point and 68 at 12 millimeters on horizontal. Radius 42 here, 100 on the other side, and radius 62, radius 66, this dimension, radius 6. We apply all these dimensions right now. Standard millimeters, XY plane, and the line of 33 length. I write here 33. Its center point is placed on the same vertical with the center point. This midpoint with the center point. Two names. And 100 is the distance. Yes. Now we use the tool arc with center point to draw an arc at a distance of 30, as I said, to somewhere here, and another one at 12 on the same horizontal with a radius of 68 to somewhere here. Now we ensure that this, I draw a line to connect these two ends. This line, it is horizontal, but I don't know if it is on the same, if it contains that point. It doesn't, yes? Okay. Then I apply coincidence between the line and the point. You see, this point is not on the same horizontal. I place it on the same horizontal. Good. Distance of 12, I said. Between who? Between this line and this arc and this arc. 12. Then be careful, I draw a line which is an arc. You know the procedure. Tangent to this left end. Same for here, to this end. Then I apply radius 42 here and 100 to the other. What we obtain? A fully constrained sketch, my friends. Yes? Good, but this is not all. If we go to the drawing, we have to apply this. Radius 62, radius 6, radius 66 at 21, and 42 is the dimension up here. Or let's do this all. I'll draw an arc, my friends, for the beginning. This is the arc. Now is tangent. I apply the dimension, which is 62, and then line as arc. An arc somewhere here, then another one in the air. Why? Because I dimensioned them. This is 6. This is this dimension is 42 minus this one as an expression, and we know that the distance from this point to the line is 21, the center, and the radius is 66. Very good. Now I connect these 2 points. These 2 points with an arc. Arc between these 2 points. Tangent to both ends. Tangent here and also here. Now we have a fully constrained sketch with this added combination of arcs. I arrange these dimensions a little because this will be the basic sketch and I want it to be very, very clear for everybody. We'll use it in the future. Okay, that's good, but not enough. Now I intend to create a path or rail in the middle distance from every point here, so that I will draw some lines, radial lines. Look here. This is the first. From one side to the other. This must be coincident with this point, 42. Yes. Then I draw another one. Line. From a side to the other. Another from a side to the other. I am very careful to catch points, but not the separation between arcs. This is vertical, this will be vertical, but I place this and I make it vertical with the center point. This is the center point. And the last line is this one. Constraints. This must go here, this here, the other also here, and not the point but the line to be coincident with this point. You see, this was not on the arc, so that I apply extend. Angles. Angles are dimensions like any constraint. 40, 25. They are selected arbitrarily by me, and you can add any other lines. I want to see if this is on the same. It was not the same horizontal or coincident with the center point. I selected these lines arbitrarily, as I said, and you can multiply them to be more rigorous. Yes, to have a better continuity of the rail. Yes, you will select any other solution as you want. Yes, they are as I want to be. Now I draw that rail as a spline interpolation from this midpoint to each midpoint of every section. As you can see, I select midpoints only. Okay, 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 and that's all. Here I place perpendicular this end to this. You see, fully constrained. But I add this perpendicularity and it will be also fully constrained at both ends. See? You can add any other lines or sections as you want, my friends. It is not simple, and be careful. If I can do it at 78, then surely you can too. Yes? I am 78 this year, my friends, and I work for the students of the world, as you can see. Good. What now? What to do now? You'll see, it's very interesting. We have to study a little the drawing and the part. Let's start with the part. You see, there are two faces, this one and this one, which are not plane. They are curved and very different from what we used to make in a drawing, in a modeling. Yes. Also here we have another surface. This ends with a cylindrical. This is cylindrical, and you'll see what is the procedure to obtain it. But these are random surfaces, as it seems to be. Good, but what is the definition? We need a definition. We are engineers, yes? The definition is right here, my friends. This simple section is all we have. We know that this ends with a circle, but until this angle of 40 degrees, we have to use this section with its dimensions. 50, where? 50 is here, between this point and this point, because this is the section AA. And 33 and 15 at the two ends. I prefer the angle here, but the original drawing doesn't have any angle here. It has 15, 33 and dimensional 50. Yes? This is 33 diameter. Timoteo was very careful with everything here, and we respect each dimensions with a limit, of course. I don't apply 16, this 16, what is this? Yes, but the other 21, 66, 62, 6, the distance 6 is here, obviously, and 42 is here. Yes, I don't, I'll verify if 42 is okay, but I cannot place this as a definition. Okay, then we go to our sketch and we try to respect everything here. The sketch is this one, and we have to create sketches, one as a circle, then 1, 2, 3, 4, 5, 6, 7, 8 sections. 8 sections, my friends. Let's do this. We create a plane perpendicular on the XY plane, but containing this line at 90 degrees. Okay, this is for a sketch. This sketch is a circle. I project points, this point and this point, to draw a circle, because 33 is the dimension for a circle. Finish sketch. Yes. Let me name this as a basic sketch. F2 is to open the text line. Basic sketch. And this is F2 section 1. Yes. Finish sketch. I use Alt V to hide the work plane, because we create a lot of planes. Other 8, so that we'll have 9 sections. Plane XY line. Okay. Sketch. F5 to have the same view in attention, and project these 2 lines. Two points, excuse me. I draw a circle with these points as a definition, and now I have to draw 2 lines. I don't know where to place these 2 lines, so that I go to the one which has dimensions. This is 50. This is 50, and it has full definition, so that I let this a while to be there, and I go to the other one, this one, and the plane XY, to create another sketch. You see how it looks. Yes, I select the plane, I apply new sketch, F5 to see the same presentation. I project this endpoint, I project this endpoint, I draw a circle with the center here. I projected this other point. Wrong, my friends. This is the point. Circle with this center, green point. A green point always. And now we draw two lines. We have dimensions for them. One is from here to somewhere here. Then I project the diameter, this diameter, and I apply construction for it, then mirror this line about the construction line, which is the center line. Apply. Then I apply the two dimensions, which are 15 and 33, as you know. 33 here. Good, fully constrained. Yes, but I have some other things to do. I apply an angle here because I prefer to use angles which are the same all over with accepted parentheses, because this is driven dimension or driven dimension. Yes, you can swipe them. For instance, you can select this. I apply escape. You can select this as a driven dimension. You see, now it has parentheses and I have one dimension to add. Then I select this and I make this as a dimension. Yes, fully constrained. Why should I do this? Because I want to give a name to this dimension using parameters. The last dimension is this one, so that I place here the name cut angle. Cut angle. This is a cut angle with its value. It has a lot of decimals here. Of course, we use only two, but they are more than two. Now I apply split on this arc and split on this arc. You saw there were 2 points there, and now I have one and another one. Why? I'll tell you after you think a little. Yes? Good. Why should I apply split? Because I don't want to have these two arcs as normal lines, but construction lines. Now we know 33 and cut ang. Cut ang as the name of this dimension. 15 we forgot. it. Finish sketch. This is what section? 1, 2, 3, 4, 5. This is the section 5. Section 5. This is the section 2. Section 2. I hide this plane, visibility, and I go back to the section 2. Now you have to be very careful because it is really interesting. I hide this sketch, visibility, where is it? Dimension visibility at least. Then I work in this plane with the circle. I draw two lines. This is the first and the other is a projection of the diameter, which must be construction to apply mirror of this line about that construction line or center line. I apply dimension of the angle between these two. I want to apply the angle, and I go to the parameters, list parameters, and I see that only one is available. Yes, because this is the one named by us. Okay. I also apply this dimension, even if I know that this is a driven dimension. Why? Because this dimension, which was 33, depends now of the ratio between this diameter 37 and the other one, which was 50. You understand this, I'm sure. You are engineers like me. Yes? I dimension here this dimension, and I apply the ratio, which is this dimension divided by 50, and this ratio, which is unitless, yes, multiplied with the value of 33. You understand? Yes or no? Yes, yes sir, I understand. Good. Now I apply the routine. Split 2 points, 1 point. Now I can answer you. And here again. When you split a circle, you cannot split the circle in 1 point, my friends, because this is geometry. It remains a circle if I cut 1 point, because 1 point has no dimension. This is why when you select the first arc, you receive 2 points of intersection. Good. I select this arc and this arc, shift to select the second one, and I apply construction. Finish sketch. The name of the sketch is section 2. Now I apply Alt V to hide that, and I also hide this section. I hide also this. Now we have here and here. We go to this one. You know the procedure, and I repeat, if I can do it at 78, then surely you can too. Plane XY, the third section, OK. New sketch, F5 to see the same angle of vision. I project directly the diameter, my friends, because I can draw a circle by finding the midpoint of that diameter and the end of diameter. Then I draw two lines, as you know, one and the other is mirrored. I apply mirror between this line and the diameter. Apply. I make this as a construction. Don't forget this, because we'll select sketches to apply loft. This is my intention, to apply loft. And we select sections with a very clear contour, not to select this area or this area or this area. We have to apply split to the two arcs and to make them as construction in order to have a contour with correct sides. Now we apply the scheme, our scheme. This angle, which is known now, cut angle, the diameter of the circle, now it is not circle. I apply dimension of diameter. I have to place this before to cut there. This is the driven dimension, but very useful for us because we create an expression. This is that dimension, which is this diameter smaller than 50. 50 is the maximum one, multiplied by 33. Always 33, always 50. Good. This is to be hidden, and we finish the next section. We place the name third section 3 is this. Good. Section 3. I don't want to see section 3. I go to section 4. This is the section 4. You see? 1, 2, 3, 4. I don't want to see this one either. Section 1. You see Alt V here? You can apply Alt V to make the same thing, to hide that this is the section 4. Plane, XY, section 4, OK. New sketch, F5, projection of the diameter, circle, center, and when it's green is good. Line from the circle to the circle. When you see two yellow points, you know that they are connected. Then I apply mirror of this line about the diameter. Apply. Done. The angle is cut ang. Cut ang. And the diameter is this one. You see, I place it before cutting with split. Then the formula. You know the formula? Yes, sir, you answer. Distance between these 2 points must be the ratio between this small diameter, very small difference, divided by 50 multiplied by 33. I can select this and copy. Yes, do like this with divided. Control C. If we have to work with this, let's make our life easier. Then I make this not dimension but construction. I apply split, 2 points of split, 1 point, 1 point. Now this and this are construction. Finish sketch, select Alt V, section 4 is this one, section 4, OK, and section 4, oh, this is not construction. Double click on section 4, F5 to see the same, and why are not? They are construction. Finish sketch. I don't see construction here. Let me see to another. View, visibility. Oh, this is the initial line. Yes, our projection is really hidden. not hidden, construction, and this is visible, this one, origin of the projection. Okay, now I go to the sixth section. The sixth section, 1, 2, 3, 4, 5, 6, 8, 9, 10. There are 10, not 8 sections. This is the sixth one. Plane, XY, this sixth. Diameter, new sketch, F5, project diameter, make it as construction to have no problems, then a circle from the midpoint to one end of the diameter with green, two lines. The first is wrong. Line from this point to this point, and the other is the axis, which is the diameter. Mirror that last line, mirror line is this one, apply, done. Angle is cut ang. Okay, diameter of the driven dimension, accept 48998, and then the last expression, which is this diameter, and Control V. Yes, because always we use always this expression. Split 2 points, 1 point, 1 point. Then this and this must be construction lines. Finish sketch, select plane, Alt V, name this sixth sketch, section 6. Okay, we go to this one, but let me make this Alt V. Good, this was, and now we go to this. I apply the tool plane, XY. This is the seventh section. Okay. Plane, sketch F5, project diameter, circle, midpoint, green, and green. This is right, this. line from this point to this point, then mirror line about this axis, apply, done. Dimensions, angle, angle is cut angle of cutting. Then diameter as driven value, because we apply that marvelous expression, which is this, and Control V. Now we have three entities to be made. Construction, because the diameter was not changed to construction. Good. You see, only this is the sketch. This is not taken in consideration, this is not, so that we have a close contour uniquely defined. Alt V, Alt, not Control. Then this is the sketch 7, not sketch but section 7, and we make it also invisible. 7. I number again because I'm wrong. 1, 2, 3, 4, 5, 6, 7. There are 9, not 10, not 8, not 10. This is 8. So I select, I use the tool plane, work plane. I select XY, I select this line, perpendicular, and now a sketch. A sketch F5 to go back, and we project the diameter. We draw the circle from this center to this point, and we draw two lines. You observe what is the order. I draw, I make a trapeze, say trapeze, with the major side to the center, not outside. Then I apply mirror of this. What happens? Mirror this line about the diameter, apply. Done. Now dimensions, angle, cut angle, once again, dimension, angle, cut angle, okay, diameter, driven diameter, dimension, accept, and then the last distance of this section, which is this one, Control V. Okay, then split, double cut, single cut, single cut, and then I select 1, 2, 3 to be entities with the attribute construction. Finish sketch, select plane, Alt V, name the section 8, section 8, and make it invisible. The last is this one. You'll see this is not the last, but I reserve my continuation to the future. Plane, this, okay, project, not sketch, first is the sketch, F5 to go back, project diameter, apply the tool circle, center is right here on the green to right here on the green. Lines, this is the first, mirror of this line above the diameter and apply. Good, done. Now dimensions, angle, which is cut ang, cut ang, then dimension driven, dimension is 26, integer value. Why? Because there is the distance between 12, 68 and 30. You can calculate for yourself. Okay, this is the special dimension, which is driven, and Control V. Okay, split, double split, one split, other split. Construction, this I keep shift, this and this, they are construction. They are not construction. 1, 2, 3, construction. Now they are. Finish sketch, select plane, Alt V, section 9, and Alt V as well. Oh yes, now we have all that. You want to see them all? Yes, I want, sir. Well, I move each plane up, as you can see. I can do this because they are before the sketches. Each one is placed also before the sketch. Yes? You understand me, yes? I cannot place them below the sketch. For instance, this is connected with this. I cannot move this down, you see? Only up. And you must understand why. Because the plane is the base for the sketch. Now I make other thing. You see, section 5 is here. I move it at its position. I can do this? Yes, I can. But why, Professor? Why? Because here is the definition of cut angle, and it was made before using in these sketches. And the sketches are now in the face of the section 5. Yes, my friends, but when you define a parameter, the order doesn't matter. Yes, I have this parameter. Where is cut angle? It is here. And it doesn't matter when you use it. Yes? It must be there when you want to use it, but not important when. Okay, I select all this and I make all visible. Wow! You see here? Yes, a lot of dimensions and so on. We start from this sketch with loft. 1, 2, 3, 4, 5, 6, 7, 8. I don't start with this one. You'll see why. Then I select the rail. The rail is this. And you see, we see the volume. Okay. Now we have this volume in a good shape. As you can see, this is the second segment of the hook. This is the second, this is the first, and this is the third, the last. Let's make the first. We select this face, we make it not visible, not normal, but construction, and we draw a circle. This is that circle. Finish sketch. We don't have the rail. the rail is in the basic sketch, so I make it visible. You see here the line is almost at the face, the entity, but not perfectly. You can try with more sections than this to make a more exactly result. Loft, sketch, sketch, and not right, but following a rail, this rail. Okay, now we have here something to be discussed later, because we cannot apply simply this fillet. The start is here and the fillet goes inside. Good. Now we concentrate on this end. Not concentrate, but focus. We focus on this end. Good. Let's see how to do. We have to create new sections here, and I project in a new sketch in the plane XY. Plane. I select the plane and I select sketch, new sketch. Here I draw a line between connections of the two, but I have to project. I project geometry. This 2, 3, 4, and also this 5 entities. Now I connect this point with this point, which are not containing this. Why? Because this is not a semicircle. Then I draw another line at random, arbitrarily. This is my feeling here, but you can use your feeling to select other better section to give you a better solution here, a better shape. Dimension from this midpoint to this line of 30. Where is this coming from? It comes from my feeling, my friends. Yes, you have your feelings. Use your feelings. 15 degrees. Then other 3 lines. Horizontal, all of them. Not there, but I use this face to see what we do here. Line. 1 horizontal. Escape. Space. Space is repeat. Escape, space. 3 horizontal lines. Trim. I trim this, and other 3 ends. Then I apply dimensions. 3 millimeters here, but it follows this arc and we have another arc here, so that we have to trim this. Be careful with details. Yes, then another dimension which is 12 from the base. And the last, which is 20, my friends. Finish sketch. Now we have to apply again 1, 2, 3, 4, 5 sections. Yes, it is difficult, but we want to obtain something very, very nice and clear and correct. Plane XY, diameter, sketch F7, F5, project the diameter and draw the circle from the center point, which is here, to the end, green end, which is this. Then 2 lines, even if we draw only 1 line, because the other is existent, and we create a second line with the tool mirror. Dimensions, angle. You didn't forget this value. Yes, it is cut ang. List parameters, cut ang. Oh, my age is the motif of selecting points, lines, entities. Then the expression, which is this driven dimension, and Control V because the computer memorize. Okay, split 2 points, 1 point, 1 point. Then construction. This I keep pressed the key Shift to select all in one step. This is good. Yes. Finish sketch. A new plane is here. Alt V. The sketch is a new section. Loft 1, Loft 2 includes another section, which was section 2.0. Section 2.0 because was or 1.0 1 underscore 0. You know what is this, yes? Is the sketch before, and this sketch is the segment 3. Let me name this segment 3, and this is the sketch number I don't remember. Number 10. Section number 10, my friends. I want to put names here. Section 10. Good. Section 11 is here. Plane, XY, diameter, OK, sketch, F6, F5, excuse me, F5. And now this is the target. I project the target, because I cannot draw a circle without projection. Look here. Where is the center? Nowhere. Where is the end? Nowhere. Project the diameter and then the circle. From center to end. Good. Lines. This is not good. Extend and go there. Mirror this line about the diameter. Apply. Done. Cut angle. Ow. Control Z once again. I click the button and my hand is somewhere else. Cut ang. Okay. Diameter driven. Dimension and the special dimension here made with an expression. Driven, Control V. Okay. We have a system, we have a procedure. We can teach anybody. Alt V, and this is the section 11. Section 11, which must be not visible. Why is this visible? It must be not visible. And now we go to the 12th section. Plane, XY, perpendicular, sketch, F5, and now 1, 2, are we here? Let's see. If I project this, it will be somewhere else. If I project this, it is in the plane, somewhere else with ends. Okay, circle midpoint, end point, the other end point. I cannot catch the point. Now I can. Line, once again, this is not good. Now it is, if I make it larger, mirror this line about this line, apply, done. Angle, cut angle, okay. Driven dimension, expression from end to end, this Control V. Okay. Split, split 3 times. Now you know why. I select this, select diameter, select the other arc, make them construction. Oh, what about this? Control Z. One line is not well placed. This one, you see, this is not connected here, I suppose. It is. What is the problem? Fully constrained. You see, this is not cutted. Split. You see, this is not. I missed this point. You have to be on my side, my friends, when you see such mistakes. Okay, finish sketch, plane as not visible, Alt V, sketch is section 12, and Alt V. Now the last 2 sections. Plane, XY, diameter, OK, sketch, F5, project, diameter, circle, this is the center, and this is the end. If I catch it, I catch it. Align, oriented from this to this end, which is outside. Trim is, no, it is okay. Sorry. Mirror this line about the diameter. Apply. Done. Select, not split 2 points, 1 point, 1 point. Select construction lines, angle. Oh, I forgot to apply diameter, so that I have to select diameter. Cut angle, okay. Dimension here is diameter. Accept, and then the last dimension, the most important one, based on this value, Control V, divided by 50 multiplied by 33, and you now know why. Finish sketch, select plane, Alt V, give a name, section 13, then Alt V. The last one, my friends, is this one. XY with this diameter. Okay. Sketch F5 to go back with the view. Project the smallest diameter in the lesson. In this lesson we have the smallest circle. Here we draw lines as we learned. Mirror about the diameter. Now I don't split, but I apply dimensions first. Driven and angle, cut ang, okay. Distance, which is this small dimension multiplied and divided and multiplied, as you can see, to obtain this. Now split 2 points, 1 point, and another one. I select, keeping shift pressed, I select 3 entities to make them construction. Finish sketch. Very good. Alt V, section number 14, section 14 and not visible. Once again we group work planes one after another to select all of them, all the sections. You see 10, 11, 12, 13, 14. Good. To complete the work, we have to add this face. Section and no section sketch. And I don't use rail to apply loft. Yes, I make all of them visible. Let me give a name here to be consequent. Section start is this one, and it must be placed at the beginning. Let's see how they're if I make them visible. Oh, there is a circle here. I didn't apply there. Which sketch is this? This is 1, 2, the second. This is. Double click on it. F5. I didn't apply split and so on here. 2, 3, cutting. Then I select. What happens if I leave this in this situation? When I apply loft, it stops because there are many closed contours here. 1, 2, 3, 4, because this is also normal line. Now it is not. Finish sketch. Now we have only that contours we want to have. I will hide both this sketch, basic sketch, which is hidden, and segment 3 sketch. And also basic sketch, visibility. We have to use only sections with only one closed contour to apply loft, and eventually rail. Loft. 1, 2, 3, 4, 5, 6, and OK. Good, this is visible. Now it isn't. OK. Now let's see how to create that fillet here. As you can see, and how I said at the beginning, this section BB is this one, and the line goes to this radius. In other words, perpendicular on this plane, this yellow plane, is this axis, so that we create an axis, my friends. Axis here and a point in the middle, this point. Now we can create a plane perpendicular on this axis, which contains this point. Yes, and we draw now sketch. You see, this point is right perpendicular on this plane. F7, we project the arc here, so that we have a good start for a construction. Which is with this lane of 25, then a perpendicular of also 25, and an arc perpendicular. Yes, 2 dimensions needed. Let's see what are that dimensions. I didn't connect this last point. This is with 2 dimensions, horizontal, vertical. Yes, point to end point. Now is fully constrained. Let's have a better view. You see what happens. Okay, finish, then extrude. We can enlarge this plane always. Auto resize to have a better image eventually. Extrude, cut, symmetric all the way. Okay. Alt V, Alt V, and the point Alt V. I don't want to have garbage on my work. Now I apply mirror above the plane XY. This is the plane for now. Let's apply mirror directly. Mirror, last feature, mirror plane is XY, and you see what is the result. Okay. Good. This was radius 25. Then we have a cylinder with a thread 30, 65, 40. This is very easy because we have a face. We draw a circle of 30 diameter of 30. Finish sketch, extrude, this to 65, then thread, oriented correctly, isometric profile 30, the diameter is 30, and the pitch is 3.5, very large pitch. And here I apply chamfer equal to the pitch, not equal, 3 millimeters is enough. Okay, that's all, my friends. I apply material which is steel cast. I apply also steel cast all over, and eventually these two faces, one I keep shift pressed, two to be machined, polished. Yes, you can view it as shaded only. You like it? You like it. Great work is here. Let's see what about the volume, my friends, to finish the drama update. Control C, double click here, and now, oh, there is a difference, but you know why. Yes, I keep this last measure because this is what we made. Yes, this is the real result of our work here. You know why? Because this loft for 3 times are different from case to case. My friends, that's all for today. Excuse me for this very long tutorial, but I hope you will learn something interesting, important, and useful for your engineer career. That's all for today. Thanks for watching. Bye bye.